Our lesson today is talking about total internal reflection and the critical angle. First thing, I will get a separating surface between two media. The first medium is high dense medium of refractive index N dense like water. Second medium is less dense medium of refractive index N less like air. When we have a light source in the high dense medium, this is light source. Okay, light ray, when it falls perpendicular on the separating surface, making angle of incidence equals 0, it will pass in a straight line without refraction, and when it falls inclined by angle of incidence equals phi 1, you can notice that it is refracted away from the normal by angle of refraction equals theta 1. When the angle of incidence increases by this way, phi 2, the angle of refraction increases by another way, which is theta 2, by increasing the angle of incidence, which is phi 3. The light refract more, making angle of refraction theta 3, which is 90 degree. In this case, the refracted light ray, this is the refracted light ray, look at this, refracted light ray, called grazing ray, and the phi 3, which is the angle of incidence, called the critical angle. From this, we can know, or we can define the critical angle. What's meant by critical angle? It is angle of incidence in high dense medium, whose angle of refraction in less dense medium equals 90. Look at here, critical angle. It is the angle of incidence in the denser medium, high dense, whose angle of refraction in less dense medium equals 290. Law, in this case, on phi c, in this case, you can notice that Snell's law said that n1 sine phi equals n2 sine theta. n1 is n dense sine phi c equals n less sine 90. Again, returning back, n1, which is n dense, I have n dense as the first medium. Look this, high dense medium. Sine phi c, this is phi c, equals n less the other medium, sine 90. Sine 90 will be 1. Okay, return back to Snell's law. N dense sine phi c equals n less times 1. Now, sine phi c from dense medium to less dense equals n less over n dense. Looks like relative refractive index. This is the rule of the critical angle. And when the less dense medium is air, the second medium is air, n less will be air, n less or n2 will be 1. Therefore, sine phi c from denser medium, dense, to air will be 1 over n dense. Problems about this? If the critical angle of glass equals 45, find the refractive index. Okay? Phi c from glass to what? To air equals 45. Find its refractive index. The rule is sine phi c from glass to air equals n air over n glass. N air equals 1. Ng, we wanted to calculate it. Sine 45. Ng will be 1 over sine 45. Ng equals root 2. This is the first problem. Transfer to the next one. If the refractive index of water is 1.33, find the critical angle of water relative to air. Okay, sine phi c from water to air equals 1 over n water, or n air over n water. 1 over 1.33 from water to air. Use your calculator to calculate it. Who can tell me? 1.1 over 1.133, and after that shift sign answer. You will get the result phi c 48.75 degree. This is the answer. I think that is very easy now. Transfer to the next one. If the critical angle between two media is 62.7, phi c equals 62.7. Critical angle, don't forget, from dense to less. And the refractive index of the denser medium and dense equals 1.8. Find the refractive index of the lighter medium. Find n less. Who can tell me the answer? Okay. Sine phi c equals n less over n dense. Sine 62.7 equals n less, which is unknown, over n dense 1.8. n less will be, you can calculate it, sine 62.7, this is times 1.8, equals 1.599 by approximation 1.6. The last problem on the critical angle. Given that the absolute refractive index for water is 4 over 3, in water 4 over 3, and that of glass, Ng equals 3 over 2. A. Find the relative refractive index from water to glass. Remember, relative refractive from water to glass, N glass over N water, N glass 3 over 2, N water 4 over 3. The result will be 9 over 8. This is N water to glass. Okay. B. The relative refractive index from glass to water. N glass to water equals N water to N glass. 4 over 3 over 3 over 2, which equals 8 over 9. N glass to water. C, which is the last. The critical angle between two media. From what to what? From water to glass or glass to water? To understand, 4 over 3 decimal will be 1.33. 3 over 2 decimal will be 1.5. Which of them is larger, Ng or N glass? You can notice that Ng or N water, Ng will be larger. Now, sine phi c will be from glass to water equals N water over N glass. Again, which of them is larger? Ng 1.5, N water 1.33. So critical angle from high dense medium, which is glass, to less dense medium, which is water. So sine phi c from glass to water equals N water over N glass. By substitute, sine phi c equals N water over N glass. I think that we have N glass, to water, or N water to N glass, 8 over 9. Shift sign answer. Shift sign 8 over 9. This will be 62.73 degree. This is about all the rules about the critical angle. To understand the total internal reflection, this is when the angle of incidence greater than the critical angle. Look at phi 4 greater than the phi c. In this case, what happens to the ray which is maybe refracted? It is not refracted. It will be reflected on the denser medium, on the water, and the separating surface looks like a mirror. And phi 5 equals phi 4, the angle of incidence, equals the angle of reflection. And all the rules of reflection can be applied. In this case, we can solve some problems on the total internal reflection. The most problems which is repeated in all sheets on all exercises, this problem. Number 5 in your sheet, an illuminating body in the bottom of a basin contain water has a refractive index 4/3 and its depth is 1 meter. A light ray come out from it in all direction to upward, so a circular light space is formed on water surface in the basin. Calculate the radius of the light circle on water. To understand this, again, we'll draw the problem. Illuminating body at the bottom of the basin. This is the basin. Okay. Illuminating body at the bottom of the basin. This is the illuminating body, which is a bottom at the bottom of the basin. And after that, light ray come out by this way. This is light ray. And another light ray which is come out by this way. The last light ray which make a critical angle, phi c. Light ray at the grazing ray. Another one. Okay, this is phi c. And this is the grazing ray. You can notice that the part of light in which you can see using your eyes here, this circle of light. You can see this circle of light. Okay, now what about the depth? The depth is 1 meter, right? 1 meter here. Okay, 1 meter. Okay, can you calculate phi c if you know that in water equal 4/3? I think that you can calculate. Sine phi c equals 1/n water, which equals 1/4/3. Sine phi c equals 3/4. So phi c equals shift sine 3/4, and this will be 48 point, this by approximation, 5/9 or 6 by approximation, as you like. This is phi c. We know that this angle making alternate angle with this angle and this angle called phi c also. Now tan 48.59 equals this angle. Tan this angle equal opposite, which is the radius, over adjacent, which is 1 meter. This is the adjacent. Radius over 1. So R equals tan answer equals 1.134 meter. This is the rule of the critical angle, or the most problems, popular problems. Now, what about the application on the total internal reflection and the critical angle? Application on the total internal reflection, the optical fiber. It is a thin flexible tube of transparent material. Look at this optical fiber. Light ray falls by angle greater than the critical angle. This is more than phi c. The light ray will reflect and then falls by angle greater than the critical. Reflect another time. And also repeated this experiment until the light come out from the other side. This is called application on the total internal reflection. This is called the optical fiber. Light can reach areas cannot reach to it by this way. Okay, when light ray enters the fiber from one end with the incident angle greater than the critical angle, it suffers many successive total internal reflections because the incident angles is always greater than the critical angle till it emerges from the other end of the tube. Look at the optical fiber. This is the optical fiber. Another experiment for the optical fiber. Look at this. You can notice the optical fiber by this way. This is real optical fiber. Yes. You have a source of light here. Source of light. Source of light to light this. This is the source of light. Okay. After that, another optical fiber. Yes. We have two kinds of fiber of one layer and fiber of two layers. This is fiber of two layers. The optical fiber are made of two layers. In inner the inner layer called the core, made of glass of higher refractive index N1 than the outer layer. Why we have optical fiber of two layers like this? One, the core, first layer, and the second. The ratio between the refractive index is the first and the second, or we begin with the second N2 over N1, give a critical angle which is very small. When the critical angle very small, the light ray falls with any angle, maybe greater than the critical angle, and reflect. And to sure that the light reflect, make the two layers. So now we have two layers. Why we have optical fiber of two layers? To prevent escaping of the light, and the beam suffers from total internal reflections till it emerges from the other end. Another thing, the outer layer protects the reflecting surface from achieving to keep the light rays inside the fiber without escaping. Application. A bundle made of thousands of these fibers can be used to transfer light to places difficult to reach, as these fibers are flexible. So it is used in endoscopes. What's the endoscope? In Arabic, المناظير الجراحية, دي endoscopes, and medical operations using lasers. Lasers are also used in communications, as light rays can carry millions of electrical signals in a cable of optical fiber. We have very fast internet using the optical fibers, the cables which is made of fibers. The second application, total reflecting prism. In total reflecting prism, this prism is called total reflecting prism. It is a triangular glass prism of refractive index 1.5. We'll calculate the critical angle now from this. So the critical angle between glass and air will be 42. I think that it is 41.8. By approximation will be 42. So a glass prism whose angles are 90 degree, 45, 45, is used to change the path of the light ray by 90 or by 180. To understand this, look at me. Here I have a glass prism, 90, 45, 45. Can you calculate the critical angle? I think that you can calculate the critical angle, sine phi c, critical angle from glass to air only, not from air to glass, from high dense to less dense. 1 over ng. Ng equals 1.5. Shift sign this, phi c from glass to air will be 41.8 degree. In this experiment, the light ray passes in a straight line by this way, okay, falls, and this is the normal line. This angle equals 45, and this angle is called 45, which is the angle of incidence. By comparing the angle of incidence and the critical angle, we can notice that the angle of incidence is greater than the critical angle. Light ray will reflect by an angle equals 45 again. Now, light ray will fall by this way. This 45 and this is 90, so the angle of incidence equal 0. The light ray will pass in a straight line. The reflection totally will be 90. Yes, this is the reflection totally, 90 degree. So I can reflect the light ray by 90 degree by this way. Another prism, light ray falls by this way. The angle of incidence will be 45. Greater than the critical angle, it will reflect. And after that, this is a normal line. Look at this, 45, angle of reflection, 45, 45, and the angle of incidence again will be 45, more than the critical angle. Reflect again by angle of reflection equals 45. The light ray falls perpendicular to the separating surface. It will pass in a straight line. Now I can say that the light ray reflected by 180 degree totally. This is about the use of the prism. These prisms are used in periscope and in binoculars. I will see you now. Look at this. This is the application. Yes. Periscope. Yes. The light ray falls by this way and move reflected. Move. Another one and reflected by this way so the eye can see the shape on the water. Also in binoculars, in the field, you can notice that the light come out here. I have a prism, reflect the light by this way, another prism, reflect light, and after that you can see using your eyes from this side. This is about the binoculars. Returning back, we have another cases like this. Light ray falls by this way. This angle 30 and this angle will be 60, so this angle is 30, more or less than the critical. Don't forget, critical angle phi c equals 41.8 degree. So 30 degrees, this is the angle of incidence. Yes, it is less than the critical angle. Light ray will refract. Well, light ray will refract towards or away. No, refracts away from normal. So light ray will be by this way, will be moved by this way, and this is the angle of emergence, theta. Okay, another thing. Light ray falls by this way, and this is the perpendicular line. This angle equals 30 and this angle 60. This angle equals 60. The light ray falls by an angle 60, which is greater than the critical angle. It will reflect 60 degree. After that, 30. This is 120. All this angle 120. You get 90. So the rest will be 30. 30 compared by critical, less than the critical angle. So the light ray will refract, not reflect, away. And this is the angle of emergence, which is called theta, angle of emergence. Okay. We have many cases, but note, in the reflecting prisms, the faces on which light rays fall or from which it emerges are covered by thin, transparent, non-reflecting layers of cryolite. Cryolite, aluminum or magnesium fluoride, and this is transparent layers on the glass prism of absolute refractive index small than that of glass to avoid the loss of light due to reflection on glass. Give reason. Prisms prefer the mirror in some optical instruments. Why? We have two reasons. The first reason, it reflects with efficiency 100% of falling light, but metallic surface in mirror absorbs some of incident light. The second reason, by time the metallic surface loses its luster and its ability of reflection. The last thing, which is mirage. This phenomena, which happens at hot sunny days at noon. We'll explain mirage now to see the inverted image. Now we'll explain it. Now to understand mirage, look at me here. At hot sunny days, mirage at hot sunny days at noon. To understand mirage at noon, if you have a paved road, the layer is divided, or the air divided into layers, many layers. Okay, this is the layer, this is the layer, this is the layer. Okay, and after that we have a palm tree like this. This is palm tree. After that, you can notice with me some things here. The layer which touches the ground has high temperature and low density. As you go up, what happens as you go from down to up? The temperature decrease and temperature decrease. So I have low temperature above and high density. Now, when light ray come from high dense medium to less dense medium, now it will refract away by this way. And the angle of incidence increases from high dense, from above to down to bottom. Now you cannot that the light ray refract, increasing the angle of incidence. When the angle of incidence greater than the critical angle, it will reflect. The person can see the object on a straight line. This person can see the object on a straight line. Look at this. This is a vision. And this person can see the palm tree by this way as an inverted image. As an inverted image again, yes, the palm tree as inverted image. It is also called watery inverted image. It looks like in water. Watery inverted image. This is the phenomena of mirage. So when I ask you about the mirage, what happens when mirage phenomena takes place? At hot sunny days, at noon, the air is divided into layers. The layers which touch the ground has higher temperature and low density. As you go up, the temperature decreases and the density increases. When the layer move from high dense medium to less dense medium, it refracts several times, then total internal reflection takes place. The person can see the object as watery inverted image. This is the phenomena on mirage, which is the application on total internal reflection. Again, we search for, in your answer, we search for light ray refract several times, then total internal reflections takes place. This is the end of our lesson today. Thank you.